All right, so we will continue with our linear algebra review. And again, homework will basically be linear algebra review. And at the very end of it, you will be asked to watch a tutorial for MATLAB, how to do it. We will introduce it briefly today. And you will also be asked to simply do certain things in MATLAB, literally redo. There's a PDF file of stuff that you need to type in and see what happens, okay? And we just want you to report that you actually did it, so you will actually learn how to record what you did. It's called a diary, okay? And also don't forget any figures that pop up. Take them separately, save them separately, and then both the diary and those figures can be combined into a Word document or something else that you use for text processing. Okay? So it shouldn't be difficult. If you have questions, let us know. Email, come by office hours, and so forth. And the homework is due on Wednesday. All right. And somewhere in there, around the homework, after homework, you can also start expecting a first quiz. Give or take, at the end of the lecture, or after I complete the lecture, there will be a quiz. I'm calling them unannounced, but you can kind of gauge when they're going to happen. Okay? So just to repeat the rule, if you do need to miss the class for some reason that is excused, just email me and provide me with some documentation of where are you going, what are you doing. Maybe it's an interview, maybe it's a scheduled travel, and we'll work with that. Okay, so let's actually quickly review some of the stuff that we went over last time. Okay, so let's say that I have a vector u, and my vector u is 3, 2, and vector v is -2, 1. Okay. So I'm going to start at the end over there. What's your name? I'm going to start learning your names. Evan? I was about to call you Ethan. Sorry about that. I was like, I know it's something like that. So what are the dimensions of these two vectors?
About 2 by 1.
The 2 by 1, so that means we have 2 rows and 1 column. Now, if I wanted to do a scalar product of these two vectors, what is that?
It can't be done. You have to transpose one of them.
Yes, so basically I would take U transpose V. Can I do that? What is U transpose?
It would be a column vector 3, 2.
And then -2, 1. So now this dimension here is 1 by 2. This dimension is 2 by 1. Right?
Yes.
So formally I can do, this is essentially 2 matrices formally. They are very simple, but they're still matrices. So formally we can do the matrix multiplication because these two, what we call so-called inner dimensions, agree. Okay? So basically, how do I do this scalar product? Let me torture a person next to you. Hi. What's your name?
Saman.
Saman. So
Is it a 1 by 1?
yes, the result is 1 by 1, correct? So it's one number, scalar. Okay? And what is that number?
It should be 3 by -2 plus 2 by 1.
That's correct. So basically 3 times, so first times first element plus second times second. And this is why it's important for dimensions to match. So I have enough pairs to go and do that. So my result is then -6 plus 2 minus 4. All right. Now formally, okay, that can occasionally be a source of confusion. You can also formulate this U tau V, which is a definition of the scalar product. Okay? It's also basically, in this case, U1 V1 plus U2 V2. So those are those matching elements. Or more generally, it's sum from I is equal to 1 over 2 UI VI. So this is writing it in terms of a sum. And then you go as many elements as you have. If you have n, it would be n, not 2. So formally you can do that as long as vectors have the same number of elements. Okay? So when I ask you whether something can be done, then you can say, okay, in this case, it can be done. Both are column vectors because this U transpose V assumes column vectors. Okay? So, but if I gave you two row vectors, you can say, well, technically, based on this U transpose V, I cannot do this. I'm not going to get a scalar product. But if I just look at the number of elements, I can apply that other formula and I could do a scalar product that way. Does that make sense? Now let's see actually, so that's an interesting thing. Let's say that I actually had U transpose and V transpose, so I'm going to just call it U prime or something, is 3, 2. Okay, so these are now just same vectors, they're just row vectors. What would formally be U transpose V? Or U prime transpose? So that would be 3, 2. So next person, what's your name? Sad. So what are the dimensions of these vectors? So if I do matrix product, what's the result going to be?
It'll be a 2 by 2.
Right, so these are matching, that's good. And the result is 2 by 2. Okay? So that's not a scalar product. It's a product, all right. It's just not scalar product. So you have to be a little careful, and your homework will be a whole lot of practice on this. Yes?
So when you're doing dot product, you go rows and then columns, but for
So for dot product, you have to have a row times a column vector in this matrix notation.
okay, but for multiplication, it's the other way around.
This could be. So if I had actually two, so if I wanted to do this operation on row vectors, this is what I would get. So formally, vector transpose times the other vector for row vectors is going to give you a matrix, not a scalar. Okay? So this is formally, so just be careful. This, I'm going to write it down and you all write it down too. So this definition of dot product assumes column vectors. If you have row vectors, U transpose V is not going to give you a scalar because we are assuming a matrix multiplication. So just be careful. Okie dokie, so let's just do this for fun. My next victim in this row, what's your name? So could you please give me the what is the result of this operation here? So 2 by 2. 3 times it's minus 6. 3 times 1 is 3, right? Then in the second position, I will have only 2 times minus 2, right? And the last one times 1. Is this clear? So it's going to be really simple because I kind of have only one pair in this case because this inner dimension is 1. Okay? All right. So now, what can we also use this vector product for, or dot product for? There is something called angle between two vectors. Okay, so let's actually draw these two. Okay. So my U is 3, 2. My U. And my V is minus 2, 1. Okay. So this is my V, this is my U. If you remember that parallelogram rule, something like this, where would your U plus V be? at the diagonal of this. Remember that? How to add vectors? Now, if I want the angle between these two vectors, then I need to do cosine of, I'm going to write it, angle between u and v, okay, is u dot v divided by norm of both vectors, and we are using Euclidean norm for this to work out. So this cryptic thing is what I defined as Euclidean or L2 norm. And this is a dot product. So dot product we already computed, so it's minus 4 divided. What is norm of u? Let's start the new row. What is your name?
Kurt.
So what is your, what is the?
Norm of u would be square root of 9 plus 4, so square root 13.
Mhm.
And v would be 4 plus 1, so square root 5.
Okay. Does anybody have a phone? Now you could use a phone as a calculator. You could have a phone that would quickly find out. What is this number? And what would be the angle if I take? So if you have a, I hope you have a good calculator installed on your phone, as opposed to just the basic one. Negative point 4961. So what would be the angle? You're after this angle. A cosine, so you need a, that's what I mean by good calculator. Find an app that is a proper calculator with sine, cosine, and all that. Or install MATLAB on your smartphone. You could. There's an app.
I was actually using MATLAB, but I didn't know we would use cosine.
Well, so you can. Oh, in MATLAB you can as well. Cosine, sine. So A cos, A cosine.
119.7.
Hmm?
119.7.
119.7. And if you want in degrees in MATLAB, you have to do A cosine D. Otherwise, you get the result in radians. So MATLAB has all of the standard functions in there. Okay? Googling works really well for MATLAB help because MATLAB has a whole lot of documentation online. So you will hit that documentation just by typing, what is cosine in MATLAB? Okay? And you will probably get help on the cosine function in MATLAB. So kind of intuitive way to search for help in MATLAB works. So just type it in, you'll probably get the documentation on that. All right, and you can of course use the help from the actual file. Alrighty, so that actually gives, so does that look okay? This does look to me as close to 120 degrees. What do you think? Right. So that's basically the angle between these two vectors. Okay. We also defined a couple of other norms. I just want to finish the review of the norms here. So what would be, who's my next victim? What would be my, what's your name?
Suban.
So Suvan, what is my norm? I'm going to call it, where I'm going to write. Let me decide where to write. So norm 1 of u.
Norm 1 is just the absolute value of each of the values.
And then,
So that would be 5.
so sum up absolute values, that is 5. And next to you, your name? Jacob, so what is the, yeah, I knew that. Never mind. I'm very bad with names. Maximum? So maximum between 3 and 2 absolute value is 3. So it's essentially, let me write that out. And that is 3. You're well set for doing at least half of your homework. And then now, as part of the review, is everybody done writing? I can close this. Yes. Okay. So I will now actually open MATLAB and just quickly. It is rather intuitive. So this is what you're going to be greeted with, or at least this is how it looks on. I have a MacBook. So, but MATLAB does work on all different types of computers. So this is so-called command line. These little 2 characters give me a command line, and that is where I type in commands. We will also learn how to save commands into scripts that I can get back to later. That's going to come up in our next lecture. But let me just quickly type in. So if I wanted to type in U, if I just type in 3 and 2, okay, this is my vector U. If I want to know the size or dimensions, I'm going to say size of U. Okay, this is a row vector, so it's a 1 by 2. Okay. And then if I wanted to do U as a, or let's do V as a 2 minus 1. Okay. If I wanted to do transpose, I would do transpose as a little character here. So that is transpose. It's not a T because T would be interpreted as part of the name of the variable. Okay. And also you can also start getting used to, so there's a so-called workspace. Right now I have 2 named variables, U and V. There's one called answer that is a default bucket for anything that you're typing. So right now answer is this V transpose, but the moment I type in something else, answer will change as well. So answer keeps changing. If you don't name your result, it's just going to go into that bucket. Okay? So it doesn't last. And I can also, beauty of MATLAB is I can do U times V transpose, and that's going to be 4, okay? Or V transpose or U transpose times V, that's going to be a little matrix 2 by 2. So that's basically what we did by hand here. Yes?
How would you put it such that you create a new one for the answer? So you take another variable, C, but you want it to be equal to the answer. How do you do that?
Okay, yes, and that's always a good idea. So I wanted to store this as a C. And now C is saved. Okay, so when I type in C, I get it back. Whereas if I type in A, it's going to tell me undefined function of variable A, because I didn't define it yet. So all of these things in red, they're actually telling you what you did or you didn't do. So those are, and you're going to go through the basic exercise about this. Basically, we'll just watch, repeat what is asked of you to do just as an initial practice. Again, it's relatively easy and intuitive. Once we start programming, of course, you will make mistakes and you will get a lot of these, and that's the annoying part. You have to basically stick and work through and find your problems. All right. So those are the basics of MATLAB. Next thing is we already basically reviewed matrices. So let me just actually show you how to type in matrix. So let's say we said that for matrices that we're going to use uppercase letters. So let's say a small, who's going to give me, who's my next victim? What's your name? Yeah.
Ariana.
So Ariana, can you give me a 3 by 2 matrix of your choice?
5 to isn't it like
Anything.
okay, 2, 1.
2. And I'm going to, so it's 3 by 2. And I'm going to go on to the next row, I'm just going to type in semicolon. So 2, 1.
6, 8.
6, 8. And I'm going to close the brackets, and here it is. Okay. So this is a 3 by 2. Therefore, technically, I can multiply it with a 2 by 1 vector, right? 3 by 2, 2 by 1, my inner dimensions. So let's try which one. V was a 1 by 2, so I'm just going to do A times V transpose is a 2 by 1, right? Boom, here's the result. Can we verify? Well, we can do things by hand. I'm not going to do that now. Okay? But my point is you can use MATLAB for those things that I ask you to do by hand. You can use MATLAB to verify that you got the good result. I still want you to know how to do things by hand, and you will be tested on doing things by hand, but MATLAB can verify. All right. So those are the matrices, and just one more quick question. So this is my A. Okay. So what's your name?
Michael.
So Michael, my position 2, 2, A2, 2. Which element is A2, 2? So this is matrix A, and we said that we refer to individual elements as sort of A, I, J, where I is the number of the row and J is the number of the column. So what is A2, 2? Second row, 2. Second column, it's 1. Okay. A of 2, 2 is 1. Okay. Person next to you? Jennifer, right? So what is A3, 2? 3, 2. So second row, not first. So you said A3, 1. So basically we refer to the matrix elements by row and column location. Okay? First row, second row, third row, first column, second column. So 3, 2. Yeah. So again, formally we say Aij, where I is row, J is column. Cool. All right. By the way, don't be afraid of saying anything that you feel like saying, whether it's right or wrong. No worries. The whole point of me asking questions is to keep you engaged, because the easiest thing for me is to just do blah, 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 blah. And all of you, research says, are going to, after 10 minutes, you're going to just check out and not pay attention at all. And that's just how kind of humans work. Okay? So let's just quickly, so I'm just going to do matrix operations review in a little bit more sort of a cryptic way, so to speak. So I'm just going to review all of these matrix multiplications and so forth in notation that is more general. So you have just seen examples. Okay? This is sort of making it general for any size of the matrix. And the reason why we're doing that is that ultimately such sort of cryptic notation enables us to program. Because you want to make a program that will work for a matrix that is 3 by 2, or 7 by 8, or 7,000 by 8,000, or 1,000,000 by 1,000,000. Okay? Computer technically shouldn't care. It just goes in until it has numbers. This is the motivation to do this. So again, addition and subtraction. You will basically, if you want to add two matrices, you will go to corresponding elements in the same positions, I, J, and just add them up. And this is the way I write basically for all rows and for all columns. Okay? And I have m rows and columns. Then multiplication by scalar is simple. So if I wanted to multiply a matrix just by a number, I'm going to do that also element by element. So just to go to this matrix A, 2 times A would basically be 10, 4, 4, 2, 12, 16. So each of the elements is multiplied by 2. And then matrix transpose simply flips rows to columns and columns to rows. So element, if I have a transpose, element Ij in matrix B, so what was ith row becomes ith column. What was jth column becomes jth row. So element Ij was Aj. So if I was writing a program, this is essentially how I would define my matrix B. I would go through all of the Ij's, and we will learn how to go through all of the elements. And my line of the code would be, well, B of ij is A of ji. Done. Okay? And suddenly you have a transpose of the matrix, and that's essentially what's behind this little operation that I just showed that gives you a transpose of the matrix. There's a program behind that gets executed, and it does precisely this. All right, so now if I wanted to multiply just matrix with a vector, okay, then your result B vector, so if my A is n by n, okay, so I have n rows, n columns, my vector has to be n by 1. It has to have the same number of rows as the number of columns in A in order to be able to do multiplication. Because when I go and multiply, my B1 will be A11x1 plus A12x2 plus all the way down to A1n xn. And that's essentially taking a scalar product of this row, this column. Okay. And I will just go through all of the rows and assemble my B. So there's actually this format. It's called actually, if these are the numbers that we know, and these are the numbers that we know, so A and B we know, and X is something that I'm looking for. This basically defines a system of linear equations in x1, x2, and xn. And one of your homework assignments says, okay, recognize this matrix. I wrote 3 equations. Recognize this matrix A, X, and vector B, so that you can write your system of equations in this matrix form, which then enables you to program and work with it. So basically find the solution when you have a 1,000 by 1,000 matrix, which you don't do by hand. So that's going to be a quick segue to linear systems, which are going to be a big topic in our course down the line. All right, so this is basically this. I went ahead of myself, and I basically narrated what do you do to get the result of the multiplication. So you go this row by this column, and you match the elements, multiply them, and make a sum, and that gives you the result. Okay? Now, if I wanted to look at it in a different way, technically, this can be written, so I can go back actually and recognize here. So this B is like this vector multiplied by scalar x1 plus this vector multiplied by scalar x2. Does everybody see that? So it's actually a linear combination of vectors, and these vectors are actually columns of my matrix. So these numbers are the same as these, okay? So it's the column of the matrix. So you can actually look at this product such that this B is a linear combination of columns of A. That's just another way to look at it. And sometimes, depending on the application, it makes more sense to do that way. Okay? So my matrix vector multiplication has a column vector as a result. Okay? Vector matrix multiplication will be a row vector, okay? Because of the dimensions. So MATLAB uses this star, and I already, basically a multiply sign, I already exemplified that. So you can actually do the multiplication. And if you don't do it correctly, so what we had was, by the way, with the upper arrow, you can scroll through all of the stuff that you previously typed in. Oh, I had C, right? Didn't I have C? Oh, well. A times V transpose, right? Now, if I attempted to do A times V, it would yell at me, saying that inner matrix dimensions don't match, because A is 3 by 2 and B is 1 by 2. Okay? So 2 and 1 are not the same, and therefore I cannot do this product. So if it yells at you, it's typically right. Okay? So go back and see what you typed in, and you will find an error. Okay. So if I had two matrices, I would just continue. So you can see this matrix is a collection of columns. So you can essentially, in your result, you will multiply this matrix with this vector, and this is going to be your result. And they're going to continue each column, and you're just going to stack it up. So this is something that we did on a very small example last time. This is just formalizing it. So basically, let's say that I have a 3 by 3. I'm going to multiply this entire matrix with this column. So basically, this row by this column will give me C11. This row by this column will give me C21. And this row by this column will give me C31. And then I'm going to continue. This row and this column will give me C12. Okay? So C12 is basically, I'm going to take first row and second column. First row of A, second column of B. Okay? So who is my next victim? What's your name? So basically, what are you going to do to get C23?
For C2, third column,
Yes?
for B multiplied by the second row.
Yes. So second row of A times third column of B will give you C23. So that's going to be A21 times B13 plus A22 times B23 plus A23 plus times B33. Okay? So that's a scalar product of this row and column. Okay? Clear? So basically we just, so it's not difficult, it's just a little tedious. So the point of these exercises is to make you grateful for having MATLAB as a tool that can do that for you. But you should know what MATLAB is doing. And there's a great philosophical point behind that. In general, in your career, you're going to use a whole lot of software. And software we tend to just trust, sometimes blindly trust. But you want to know a little something about what is behind that software. And there's a number of courses that will teach you. After this, you're going to have reservoir simulation. So you will build a very simple reservoir simulator using MATLAB. I'm now teaching you fundamentals of MATLAB, and then reservoir simulation is going to put that to good use. So essentially, you want to know what are the fundamentals of the software behind, so you can verify the result, at least that you can see whether it's doing things roughly correctly. So don't blindly trust. Software is not a black box. What we will also learn in this course is that there's a number of choices you have to make when you are doing things numerically. Like, for instance, when are you going to stop iterating? You're never converging completely to the precise result. So you got to stop somewhere. And those are the decisions that somebody made for you in that software. Okay? So you have to learn to be critical. And the reason is that everything will work fine in the first 2 or 3 examples. You go to work in first 2 or 3 reservoirs. It's all great. It's some sort of conventional reservoir. And then you go to an unconventional reservoir, and actually your software cannot handle something about that reservoir. Maybe it cannot handle very small porosities. Maybe it cannot handle presence of fractures. Maybe it cannot handle something else, or you don't have a full description of wettability in your, right? So there's something that you cannot handle, but unless you kind of know a little something of what goes behind the numerical methods and the simplifications that they make, then you actually can't target like what is wrong and what do you need to change. Okay? Ultimately, you need to solve the problem somehow. Okay? So you need to go to a different tool, and you need to be able to be critical of the tools you have. Okay? So again, this is not, we don't do this to torture young minds unnecessarily. You are going to need this sort of these tools somewhere down the line. But be critical of software and what it gives you as a result. All right. So basically, you're gonna, so this is basically the point that I made. In general, if I wanted to generalize the result, I would say that Cij is the ith row times jth column, and there's this number of, the number of elements in the row and the column have to match for us to be able to do this. All right. So sometimes, this is another view is just to do a dot product, so that's fine. So there's just saying for this in 7 different ways what the operation is. Now, one thing that we have to be clear is that unlike with numbers, where 3 times 2 is equal to 2 times 3, that's called law of commutation. That's not the case in matrix multiplication. And I already exemplified that. Sometimes we're not even able to do multiplication, let alone for those 2 numbers to be equal. Okay. So basically, in the case that I had over here, A V prime, this is something I could do just as a reminder. A was this and V prime was that. Okay. But can I do V prime times A? I can't even perform the operation. So obviously, any matrix A times matrix B is not the same as B times A. Sometimes I cannot even perform the operation. If I had a square matrix, so 2 by 2, all of my matrices are 2 by 2, then I can always do it. Okay? A times B, B times A, I can do it. It's not going to be the same. I can show you a simple example. Is 2, 3, 5, 6. Okay. And my B, who is my next? So this second round, what's your name?
Eric.
Eric. So give me a 2 by 2 matrix.
1, 2, 3, 4.
Oh, okay. 1, 2, 3, 4. That's lazy, but okay. A times B. Oh, oops. See, MATLAB is kind of smart. It gave me an option. Did you mean uppercase B? Okay. Yes, that's what I meant. So this is my A times B. If I do B times A, oops, and again, did you mean uppercase? Yes, I meant uppercase. These are 2 very different results. So again, I can perform both operations, but they're not necessarily the same. In very simple cases, it's going to be the case that they're the same. But that's more like luck than anything else. Okay? All right. Okay. And I think that basically ends our discussion on linear algebra overview. And I have already essentially started some MATLAB fundamentals. I'm going to introduce it today, and then I expect you, starting next time, to install MATLAB. If you're going to work on your machine, please install MATLAB and bring that laptop here. If not, then you will bring a bunch of laptops here to class, so you can just check out. You will need your UTID to check out the laptop, and we can work. But I want to kind of just introduce you to it, and I hope that over the weekend you start working on your homework. So if you want to start with that MATLAB review, that's up to you, whether you start with, just to kind of get going. Okay? It's much easier, and it's going to be much better if I kind of show you a little and you kind of work with it on your own, and then we start working with it in the class. Okay? So let me open. Bless you. Where's my... Okay. Lectures. Okay. So this is now going to be a lecture on MATLAB fundamentals. We will start, I have just introduced linear algebra. We will start with matrix operations in MATLAB. And we will go over certain built-in functions, input, output, and plotting. And just to say what is input and output, first thing that we want to do in programming, we want to work with some numbers and some data. We need to know how to give MATLAB that data. Remember those punch cards? Okay. So once upon a time, you had to have actually these punched cards that basically had the data representation, whatever your numbers are. These days we use files, it's much easier, but you need to know how to read in a file output file. Certain things you can just type in. That's just what I did right now as I was playing with it. Okay. But if your well log has 3,000 numbers, no, you're not going to type those in. Okay. So you want those stored in a file, and you want that file read in. MATLAB has a lot of things that are kind of very intuitive and that are already worked out for you. It's a very nice environment to work with, which is why we're doing class using MATLAB. So you don't have to worry about too much. Technically, you could just import an entire Excel sheet of numbers into matrices here in MATLAB if you wanted to. So it does have a lot of built-in tools. That said, we will learn a lot of very basic tools because you never know how are you going to get the data, and we want to teach you fundamentals. Then if something is easier, it's always good to know how to do something in a very basic way. So this interactive mode, this little 2, this command line that I showed, it's so-called interactive mode, and multiplication, addition, subtraction, those are simple. You will type in plus, minus, times, just like you think you would, or you could. Okay? So those are basically intuitive. Now there are certain expressions that are not so obvious, and you just simply need to know where to find it. MATLAB has a lot of documentation coming in with it, or you just Google it these days. But if you're not on the internet, then maybe you will search in MATLAB help, and you will store variables that you care about. So if you care about having this 5 and you're going to refer to it later on, you want to store it, so you will say A equals to 5. Okay. Or B is a result of an operation. This is 2 to the 3 plus 6. And C is A plus B. Okay. Some variables are built in, so there is an answer, A and S, that's kind of reserved, so you shouldn't use it for anything else. You can. It can get confusing because if I use A and S as a name of variable, and I can name my variable anything, I shouldn't start with number or special characters, and I should actually avoid special characters like punctuation altogether. So use letters and some combination of letters, starting with letters and numbers, as your name of the variable. But if you use something that is already built in, next time MATLAB uses it, it's just going to overwrite what you thought was in there. Okay? And one common one, just a moment. One common one that I keep doing is I. You saw in those formulas I and J. I is also the complex number. As long as you don't intend to use complex numbers, it's actually okay because you never use that functionality in MATLAB. But I cannot change myself. I went through so many courses that when you have matrices, I is going to be the row number, J is going to be column number, that I simply cannot fix that in my system at all. So I is a common variable name that I use. Yes? NaN is not a number. Let's create NaN. So 1 is here. Answer, it already exists in memory, so it was whatever my last operation was. There is that pi is pi, okay? But you could do, not a number. If I divide it by a 0, that's not defined in mathematics. Mathematics doesn't know an answer to this. It's labeled NaN. So anytime you divide by 0, which you will probably do, okay? You might use porosities in your file, and some of them might actually show up as 0, and you count that they're non-zero, and you create your formula that divides by porosity. You're going to get not a number as your result. Okay. So you have to also learn how to guard against those. Okay. Infinity is 1 divided by 0, if you remember that from calculus. That's infinity, and that's defined here as I. So if you do operations like this, sometimes it's either not defined, then it's NaN, or it can be defined, but it's infinity, which is technically not a number we can write down. Okay? So those are reserved as names. So one major thing is that what I want to do is I want to do matrices and arrays because that's how data is stored in petroleum engineering and any other engineering. Basically, you store data in some form of arrays and matrices. So array in MATLAB is what we refer to as a vector. Okay, so it's simply a linear one-dimensional array of numbers, and matrices can be in any dimension. And basically there's this, so how do I define a matrix? I can type it in, I showed you how to type in a matrix, basically row by row, and you delineate rows by semicolon. Okay. There's a lot of matrices you simply don't want to type in. So we will learn how to actually evaluate a matrix based on some function, if we want to. And there are some certain built-in functions that also return certain numbers. So one common example of that is that you have a reservoir. And right now you're building your little reservoir simulator, and you need porosities in that reservoir. You discretize a reservoir, and you need porosity as a number. Right? Now, you don't know much about the reservoir. You know it's a sandstone, so it's roughly around 20% porous. So you might want to simply a distribution of numbers between 18 and 22%. Okay? So there are built-in functions that will give you sort of random numbers in that range because you don't know them precisely anyway. And that will work well. You will get a course called geostatistics that is basically handling that question in petroleum engineering. Data you have is sparse. It's never everywhere. Okay? So yeah, I might need to create myself some numbers, and there's a lot of built-in functions in MATLAB that can do that for you, so that those functions can then return a matrix of numbers that you need. Okay? And you work with them. So we'll learn that. Okay? And then of course you can program yourself functions that define matrices, or you can simply import. So your colleague actually has measurements that come in as matrix. Well logs are typical examples. You're going to have one painful example of well log that you're going to have to visualize and work with, okay, in this course. And basically, you're going to import that data from a file on the disk, and you need to know how to read it out. Files come in certain specialized formats. And I say format, that means that you know who's stored where, so you have to go and read it precisely in that order, or else you will read it wrong. Okay. So we will get on with that next week. Enjoy the weekend.
Should we bring our computers on Monday?
Yes, that's what I just said. I'm going to send a reminder. So bring your computer, try to install MATLAB before, and on my very introductory slides there is how. But I'll send a reminder. Hello, do you have a letter for me?
I emailed it to you.
Oh, good. And then maybe I didn't check my email in the past 2 hours.
That's right. Yeah.
Yeah, I was in meetings. Sorry.
Yeah. So I had you told us to talk about test conflicts, and it's not a direct conflict. So we have test April 17th. I have nationals that weekend, so I will miss Wednesday, Thursday, Friday of class, and we should be flying back Sunday. So it should give me enough time to take the test Monday. The problem is flight delay and things like that.
Anything that could happen.
Yeah.
Okay.
So
Let's just plan to have it on Tuesday.
on Tuesday?
Yeah.
Okay. I don't have the letter yet for that tournament because it hasn't been sent to me yet. But when I get it sent, I'll tell you.
So let's just plan Tuesday morning or noon, and that should give you time.
Awesome.
And if not, well, we'll have to move it, but I know it's about it.
Okay. All right. Thank you.
Okay.
I have a question about
You verify your overviews to go.
I should actually, but for this, when you
Take the time to do it. You don't have to give it.
okay, yeah, I might
Make
keep
it perfect. May as well make it perfect.
That's true. You don't. So when you're taking this was a 1x4, and it's a 4x1. This is a 4x1. This is a 1x4.
So
You get a
transform is 1x4. Yes.
You end up with a 1x1, right?
Uh-huh.
For this, and you cannot do the dot product with a 4x1.
Then you're gonna say that.
So it cannot be computed.
Testing.
Okay.
Okay.
Same thing with cross product, right? Because this is a 1x4 and this is a 3x3. Even if you transpose, you wouldn't be able to do it.
Precisely. Yeah.
Okay.
So part of it is just testing, can it be done?
Okay.
Alright.
So because and that's again warning for you because sometimes you will have these things that you will pre-program and you know you pre-program it for a certain type of data and then data of a different type comes in and you get all kinds of errors. You kind of have to be ready for it.
And you prefer it in this room?
Yes, that's perfect. That's precisely what it is.
Should I hand it in now, or
If you're safe, you can.
I feel confident?
You just
Thank
want
you.
to get it out of the way. I congratulate you on that.
You
It's like sometimes things are just done.
I was just about to ask, yeah, I realized that I can't do this because this is a scalar, this is a 3x3 and this is 4x4.
Yeah, so scalar is easy. Scalar you can always do, but it's 3x3 times 4x4. Then you write down this cannot be done because inner or matrix dimensions don't match.
Okay, I got it.
One more thing I just want to clarify here. So for the dot product, I have a U matrix and V matrix. This is I can basically like multiply this, right? So I got the answer. But for this, where to go? Like, take V transpose. But like, for example, here, if I want to calculate dot product of U and V, I have to transpose V and U, right?
Yes. So formally you can say here, well, formally U transpose V will give you 4x1 and 1x4, and that's not a scalar. That's a 4x4 as a result.
Right, but it's still we
But
can.
you could still use the other formula where you just sum up 4 times 2 if you want to. So you can just say, okay, if I take that definition as that, I can do this. Okay. So write that down. Some of this I want just the understanding of matrix operations versus. That's all.
And for the orthogonal part, I just because I do, what I did was I took a dot product of U and V and I didn't get 0, so
They're not orthogonal.
And for angle, you just use it. Okay. I don't know,
And
it's really
if
hard.
they're orthogonal, yeah, and that's good. That part of this
class
is kind of testing how cautious you are, because ultimately computers are really sensitive about how you define things when you write. So there's a reason why I'm doing this.
Alright, thank you.
You're welcome. Have fun.